Hey everyone, we're going to talk about solving systems graphically today. When you think about a system of equations, we're talking about a set of two or more equations put together, and to solve them graphically, all we need to look for is their point of intersection. So we're going to take a look at a system of two equations and graph them together, find their point of intersection, and state their solution. So for two equations, the solution will be an ordered pair. There will be two equations and two variables. So when we have an answer, there should be two values, an x and a y value. We are going to know that they are truly correctly found by plugging them back into our equations and forming true statements. So in other words, when we put our x value and our y value back into the original equations, we should come up with a true statement. Some number equals some other number, and it needs to be true. They need to truly be equal. So let's take a look at solving graphically. So we've got this system of two equations here. We've got y equals 3x and y equals 4 minus x. So we're going to graph these two lines first, and then we're going to see where they intersect. Let's take a look at these in slope-intercept form so that we can graph them more easily. So there is no number out here behind this 3x, so I know that I could put a 0 in as my y-intercept. So starting at 0, to make my first coordinate, I'm going to now move up 3 and over 1 to find each additional point on this line, since my slope is 3. So I can move in this direction here, or I can go in the other direction. Because it's all the same line, it's going to continue on in both directions forever. So let's make a nice line to connect these on our graph the best that we can. And now let's go back and graph our other equation, y equals 4 minus x. So I can see that my y-intercept is 4. So we'll start there, put our first coordinate, and then we will move down 1 and over to the right 1 to find each additional point, since our slope is -1. So down 1 to the right, down 1 right, and we can go up and to the left. And let's connect these with a nice straight line the best we can. And it would really continue on forever to the ends of the graph, but we can see that we have found the intersection point here. Let's circle that. Looks like 1, 3. X value of 1 and y value of 3. So let's remember that, 1, 3. Okay? If we say that our solution is 1 and 3, we're going to now test that to make sure that is correct. What needs to happen is we need to put this value in for x and this value in for y into both equations and make sure that they form true statements. So everywhere that we had a y, we're going to insert that 3. Okay? And for our x's, we're going to insert the 1. And let's see what happens. So top equation, we've got 3 equals 3 times 1. 3 equals 3, and that is a true statement. So we're good so far. Second equation, we've got 3 equals 4 minus 1. 3 equals 4 minus 1 gives us 3, so that is also good. So we did correctly find the solution graphically to this system of equations by finding the intersection at 1, 3. So you can always test that just to make sure. Alright, how would this apply to a real-world topic? I've got an example here, and this could take many forms, but just suppose that you were wanting to take your family to some type of event. I've got a concert here, and that a children's ticket is $1 and an adult ticket is $2. Let's say you'd like to take 8 members of your family, but you're not sure how many children, how many adults you can bring. You have $11 total to spend. Well, using a system of equations, you could figure this information out. So if we could form some equations from this information, we can solve by graphing our lines, just as we just did, and finding where graphically the lines intersect. And that's our solution. So let's take a look. All right, forming equations out of this information, remember that we had $2 was the price of the adult ticket and $1 was the price of the child ticket. So right here for this first equation, I've got 2x, which we're going to let represent our adult tickets, plus 1y for the child ticket, equals $11. Remember, we had $11 to spend. So in some combination of adult and children, we can only spend $11. So we can set it up this way. Second equation, we want to take 8 members of our family, so we can take some amount of children and some amount of adults. We don't know how many, but total, added together, we're going to take 8. So this is what our second equation would look like. And now we need to graph these. Alright, so just to graph this a little bit easier, let's look at these equations in slope-intercept form. So if I slide some stuff around here to get this information in slope-intercept form, these are the exact same equations, just slope-intercept form, so we can graph them more easily. Top line, I've got to look at my y-intercept of 11 and then move 2 spaces up and 1 over for my slope moves. So let's count up to 11. It's actually going to be a little off the grid, but that's okay because we're traveling down for our slope. So down 2 and over 1. Each additional point can be found by moving according to your slope. Alright, and you can make as many as you like. And then we're going to connect those in a nice straight line. Okay, let's move to our second line. Let's go with a different color here. So starting with our y-intercept of 8, let's count up to 8 on the y-axis. Make our first coordinate, and then we're going to travel down 1 and over to the right 1 because our slope is -1. So down 1 over each time. As many as you like. The line will continue forever, so we can extend it as far as possible through to the end of the grid. Okay, and it looks like it's possibly crossing at this coordinate right here. So where is that? So let's look. We've got 1, 2, 3. 1, 2, 3, 4, 5. So 3, 5. 3, 5. That looks like it's going to be the solution to my equations of lines here. Let's check it. Alright, 3, 5. So remember, to check, we can always go back into our original equations and make sure they form true statements. And if they do, if you want to go through the math of that, you will see that they do form true statements, so you have correctly graphically found the solution to the system of equations. What does that mean? Well, for our real world problem that we looked at, remember the X was represented by adult tickets, so that means that with our money and our conditions, we can buy 3 adult tickets to this concert and 5 children tickets, and we can choose whoever we want to take from our family out of that combination of items. And this concludes our lesson on solving systems graphically.